In this video, I want to measure the voltage across each LED and resistor to verify if my schematic circuit is correct. The voltage across this resistor is 3 volts, and the voltage across this LED is 2 volts. I want to use the multimeter to verify that the voltage across this resistor and the voltage across this LED are these numbers. First, I need to power on this LED. In order to measure voltage, we need a current flow in the circuit. I'm using these terminals for the multimeter. I will select 20 volts DC, connect the terminal on each leg of this resistor, and I'm going to power on, and the voltage across this resistor is 2.87, which is approximately 3 volts. Now I'm going to connect the terminals across the LED, following the polarity. Here is a closer look how I did. Positive, because my right here is positive and the negative. And this is my reading on the multimeter. 2.08, approximately 2, which is good. Now I'm going to do the same thing for the red LED. So I expect this one be 3 volts and the LED 2 volts. 3 volts and 2 volts. So I'm going to connect with the resistor. This and this. So I'm reading negative 2.94. It's negative because probably I should change the direction here, because remember, this is my positive. So let's see what happened. Positive, and this is the negative. So now I'm reading 2.93. And I recorded right here, 2.93. Now I'm going to connect with the LED. So the positive here on this leg and the negative on this leg. 2.02. So 2.93 plus 2.02 is 4.95. So on this branch, I should have 5 volts. That's close enough. Now, one question that you might ask, why is not exactly 5? Why is not exactly 3 or exactly 2? So the energy is fluctuating a little bit here. So there are other parts that is also get some energy from this voltage supply. The terminals of this wire, they get some energy. The connections under this breadboard, those metal pins, they are getting some energy. So that's why it's not exactly the number. Now I'm going to move it to the green light. So after consecutive readings, I realized that the voltage drop on the resistor and the LED is pretty much constant. And the conclusion of this video is that it makes sense because if 5 volts is applied across this branch, so which means there is going to be share between both components. If this is taking 2 volts, this one will be taking 3 volts. So everything is remain constant because is in parallel. So let me step up with a question. What would happen when the value of the resistor increase? So we have calculate I have calculated the value of this resistor here, which is 150 ohms. So what happens if I change this resistor to a higher value? Because the minimum value for a resistor to preserve the LED in terms of the operational restrictions, which is 2 volts and 20 milliamps. So what would happen if I change this resistor to a higher value? So let me check this out. So here I have 3 resistors. Let me call this A resistor, B, and C. I'm going to use the multimeter to measure the resistance of each one. A resistor is 198.8. Let me round to 200 ohms and see what happens. So this is 200 ohms. So before I switch the resistor, I'm going to check which one I'm going to switch. I'm gonna pick this one right here because it's easier for me. Let's see what happens. Okay, I want to comment a couple of changes that I have done to analyze this circuit when we change the value of this resistor. I remove all the other LEDs and I brought a yellow one so I can compare. So this one here is the original one with 150 ohms, and the second one is the same circuit, but now I have a resistor of 200 ohms. And what I want to check is if it's going to affect the brightness of the yellow light. I turn off the light, the ceiling light, to see if we can see any change here. So I'm gonna power on, and honestly, I don't see that much changes on the amount of light of these 2 LED. Now what I'm gonna do, I'm going to check the voltage across the resistor. So the first one I already know, and I want to check the second one. I am on the wrong dial. So 220 volts actually. So let's see what I get. So I have about the same voltage, about 3 volts. And I'm going to check the one with 150 one more time, and a little bit less. Okay, so let's see what happens when I switch with resistor B. Okay, so now let me try the resistor B. So what value is this resistor? Okay, obviously is more than 200, so I need to move the dial up. Okay, 217. I would say this resistor, the commercial value is 220 ohms. What you see here is the tolerance fluctuating up and down. So I will keep this as 220 ohms. Now I'm going to connect this resistor. A little bit challenging to see this in dark. So it's connected. This is my control group, and this is the one that I'm changing. So now let's see if I observe the brightness of this yellow LED change. definitely not that much. And now let me see the voltage across this resistor. Okay. Actually, let me connect the positive and the negative, and almost about the same, 2.92, 2.93, no changes. Okay, so now let's try this resistor. I need to change the diode to resistance and measure. The value here is, oops, obviously is more than 200 and 326. Okay, 325, 300. Let me keep 325. Okay, so now I have my control one, which is 150 ohms. And now I have this new one, which is 325. So let's see if I observe the brightness of this LED change. No, I don't see any change. Now let me check the voltage across. Actually, I have to change here to this. Voltage across this resistor, which is 2.9695, fluctuating about the same. Okay, because I'm not seeing that many, I don't see any change in voltage and the brightness of this LED with the change, with the increase of the resistance. I start with 150, that's what I have originally. And then I increase to 200, then 220, and then 325. So I have this resistor that is 1,000 ohms. So let me check the value here. 1,000. It's hard to see in the dark here, okay? So the value 9999 is 1,000. Okay, so let's install and see what happened. Okay, this time I do see a change here. This probably in the video doesn't show as much, but this one is definitely dimmer comparing with the original one. So now let me check the voltage. So the voltage goes back to 20. So the voltage here of these 1,000 ohms is I see that, over 3, little bit. So 3, and let's see now the voltage on this one. And yes, so remains around 2 volts, but yes, I see a change here. So let me try with a resistor higher than that. This resistor is 5K or 5,000 ohms. So let's see what happened. Wow, big change here. Now this time, this LED connected to the 5K is way dimmer than the other one. So now let me check the voltage. So I'm going to move my dial to 20 and let's see what I get here. Wow, 3.12. So is definitely higher, not as much, but in terms of electronics, small voltage is a big deal. So yes, finally I can see a change here. Now the bottom line is all that we should care is that the voltage across this LED is 2 volts. So then what I'm gonna do is with this scenario, so let's check the voltage across this guy. So is 1.87, which is still, it's in the range of its operational requirements. And as a conclusion for all this is that if you want to install a LED and you are not sure if it's going to damage the LED, as long as you have its minimum value, which is 150 ohms in this case, because that matches with the operational requirements for the LED, which is 2 volts and 20 milliamps. So that means that any resistor above 150 ohms will be safe to install in series with the LED to prevent any damage. So anyone will be safe. So let's say you are running a lab and you don't have a specific resistor. So as long as your value that you have is above and you don't mind to have a dimmer light like this one, so that should be fine. Now, before I end this lab, I just want to know how these other colors will respond to such a high resistor of 5,000 ohms. So let me check. So this is the green light. It does work really good with 5,000 ohms. So the red one is on, but is super dim. This is the blue one. It's dimmer, but looks good. So the one that I actually noticed that was very, very low in light was the red one. In conclusion, in this experiment, I want to observe the brightness of a LED with the increase of resistance in series. I also wanted to measure the voltage across the resistor as it increases its resistance. To proceed with this experiment, I selected the minimum resistance of 150 ohms that meets the LED requirements of operation of 2 volts and 20 milliamps as my control group. So this circuit, I didn't change anytime. This here is my control group with 150 ohms. Then on my experimental group, I increased the resistance gradually from 200, 220, 325, and I did not observe that many change with the brightness of this LED and the voltage across the resistor. Then when I changed to 1000 ohms and jumped to 5000 ohms, which is the one that is installed right now, this one is 5000 ohms, then I can observe that the LED became dimmer and the voltage across the resistor has increased. I also replaced the experimental group LED with those different colors, and the red one was the one that was the least bright, was actually very, very low in light. The other two, they kind of respond the same way that this yellow is doing right here. So it's safe to say that any resistor greater than minimum value, which is 150 ohms, can be used to operate a LED. Will be the brightness will be affected, but everything will be preserved.